Hello, my name is Vishen and welcome back to another video. In this video, we're going to be creating a password manager with Python. And I know I'm pretty sure it's been a little bit over 2 months since my last video, but I'm hoping to get back into it with this one. Okay, so to start us off, we need to first think about what packages do we need. And so to do that, I'm just going to create myself a virtual environment real quick. So while we let that load, I'm going to talk about, we're going to need cryptography for this. And cryptography is probably the best, or at least in my opinion, the best package to be using in Python for anything that requires encryption and decryption and security of that sort. So I have to create a virtual environment real quick, and remember, always create that virtual environment because you don't want to be installing things into your system pip. And so with this, we're going to do a pip install cryptography. So that's going to install. And while that installs, I'm going to create a file that's going to store all of our code. And we really only need one file for this because it's going to be done in the terminal. And we're not really going to be doing anything too fancy with it. So while that's installing, what we're going to need for this is we're going to be using JSON for our storage. And JSON because that would be the JSON because the simplest for the sake of this tutorial, and we really don't need anything SQL fancy because I'm sure you guys can implement that by yourselves. So we're also going to import OS just so we can generate some random salts that are in byte format for our encryption. So while that's installing, I want to talk about the 4 key functions in a password manager. And I'm pretty sure this is self-intuitive, so take a second to guess before you listen to me explain it. So what we're going to need is a function to encrypt our password. And we can worry about the arguments later, and we can worry about the definition later. We're also going to need a function to decrypt the password. So same thing here, we'll worry about everything else later. We're also going to need a function to add the password to our manager. So we're going to do the same thing here. And then we also want to do something with getting our password from the manager, to get password. Okay. And so now that our cryptography is installed, we're going to need to import three classes and functions from some of the subfolders of cryptography. So we're going to start off with fernet. So from cryptography.fernet, we're going to import the fernet. Okay, and then from cryptography.hazmat.primitives.pbk.df2 import pbk df2 hmac. And then from cryptography.hazmat.primitives import hashes. And don't worry if you don't understand this yet. I'm just going to go over what each of these do when we get to that portion of our code. And we're also going to want to import base 64, just so we can use that for creating our key file, which is very important when we're doing this. So what is fernet? So fernet is an implementation of symmetric authentic cryptography, which is secret key cryptography, and that's what we're going to be using for a password manager, and that's typically what's best for a password manager. And then for KDF is a key derivation function, and this is very useful for generating a key that we can use. And PBKDF2 is a password-based key definition function, and it's the second one that this package has, so we're calling it 2. Okay, so now that that's out of the way, we can actually start to talk about what we need to pass into encrypt password. So the way password managers work is you have a password that gets passed into, you get a password, the master password, and that's used to encrypt literally every password that you store with the salt. And we use the salt because unfortunately, if you have a lot of passwords that are encrypted by the same symmetric key, it's actually very easy to reverse engineer and find the master password. So we add a salt, and that lets us do everything. And the reason we encrypt all these passwords with the master password is to make sure that the master password is the only thing that could possibly decrypt all of these. Okay, so to encrypt a password, based on that logic, we're going to need to have the master password. We also need a password that we want to encrypt. And in decrypt password, based on that same logic, we're going to want the master password, we're going to want the password, and we're going to want the salt that we used for encryption. And we're going to want to store the salt wherever we store the password just so we can decrypt it. And then for add password, we're going to want the master password, and the website that it's for. And get password similarly, we're going to want the master password and the website. Okay, so let's start work on our encrypt password function. So the first thing we want to do is generate a random salt that we can use for our encryption. So os.urandom, we're going to generate that as 16-bit. That's okay. And we're going to do the same. Then we're going to start creating our key derivation file. Key derivation function. So KDF is what we're going to call it. Is PBKDF2HMAC. And with this, we need to pass in a few arguments. So the algorithm, this is basically like the hashing algorithm. So we're going to pass in SHA-256 because this is industry standard. We're going to say that the length of this is going to be 32. The salt that we're using for this is the salt that we generated. And iterations, this can be pretty much anything, but I think 48,000 is what the doc suggests. So that's a good number to keep in mind when you do it, when you use this. Okay, so now that we have our key derivation function, we can use that to actually derive our key. So we're going to say that our key is going to be, and we're going to use base 64 just so we can encode this in base 64 format, which is also the standard for this package. And you can look this all up using the docs. I don't think I'm just an expert on this. It's all in the docs. And then we can say kdf.derive, which is the function, which is the method of kdf that we can use to get our actual key. And then we're going to encode our master password in bytes and bits. Okay, because when we're dealing with encryption, we don't want to pass things as plain text. We want to pass things as the byte representation of that plain text, and that's just for security reasons. And so now we need to create a fernet of this. Okay, and remember how I explained what fernet is? Just go back to that if you need to refresh your memory. But fernet, and we're going to create a fernet of that. Okay, now the fernet is an object that we can use for the symmetric encryption. And so we're going to say our encrypted password is going to be equal to, using fernet as our encryption method, we're going to encode our password and we're going to encrypt it using that key. And then what we're going to do is we're going to return the encrypted password and we're going to return the salt that we used. Okay? And now, if we were to decrypt this, right, we're going to do the same thing here. So we're going to create our KDF again, and we don't need to do the salt because we already got the salt from here. Okay, and so we're gonna do the same thing, exact same thing. I'm gonna get the SHA 256 length equals 32, salt equals salt, iterations equals 48,000. And one thing to know here is we can't exactly use salt here because of an issue that happens when with storing it in a JSON file and storing it in Python in general. So salts created by OSU random use Latin 1 instead of UTF-8. So when we store it in our passwords.json, it actually gets converted to UTF-8. So what you want to do is convert this into Latin 1. And this is because, like I said, the OS UR random gives you a byte string in Latin 1 format. And so there's no dash here. So Latin 1 important if you're going to use random. And so we're going to create the exact same KDF. And so from there, same thing, we're going to use base64, URL safe, b64 encode. We're going to derive a key, and we're going to encode that master password. Create the fernet again. And then we're going to return f.decrypt instead of encrypt this time. And we're going to encode our password to do so. Okay, so that's actually the entirety of like all the cryptography stuff that we'll have to deal with in our password manager. And it's really, really simple. I hope you guys were able to understand the main logic behind it. And you don't really have to understand the functions, exactly what they do, but if you want to, you can take a look at the docs. Just know that this is how you would use them in the password manager setting, and it's very easy to apply them elsewhere. Okay, so let's start work on the actual adding of the passwords. Okay, so we're going to grab our encryptor and salt, and we're going to get that by encrypting the master password and password using the function that we just created. So like we said, this returns encrypted and this returns salt. So we're just going to grab that once we encrypt the password, and we're going to have the encrypted password right here. Now we want to store this in our JSON, and if you're not using JSON, then you can pretty much ignore everything I say here. Passwords.json, we want to open it in read mode as file, and then data is going to equal json.load file. And then if the file does not exist, meaning we can't use the JSON decode error, data is going to equal an empty string instead of an empty list instead of what it normally would be, a list of website entries. And so we're going to create our entry here, and that is going to be, we're going to say that the website password is going to be encrypted. And normally we could do this, but you see here we encoded the password, so now it's actually in byte format, so we want to decode it before we shove it in there. So decode it, and then the salt, what we want to do with the salt here is we want to decode it from Latin 1 just to avoid any issues with storage. Okay, so that's actually the entry, and then we can append that to our list, and that's the entry, and then we're gonna write it to our passwords.json file, and json.dump data file, and then indent equals 4 just for semantics and style. And then it's actually going to be really similar for get password. And I'm saying really similar a lot this video, but everything is really, really similar. For get password, we're going to try to get open password.json in R mode as file. We want to load the data, and then we want to accept if the file does not exist or there's nothing in the file. We want to say data equals for entry in data if entry website equals website. So we're going to go through every entry in here because see, we're storing a list of JSON objects. So we're going to go through each entry, each item in that list, and see if the website is the website that we want to do. And if it is, then we're going to grab the password from that. And we're going to grab the salt from that. So not salt, and food. And we're going to say the encrypted password is going to equal, if we were to decrypt the password using our master password, the password, and the salt like we used. And then we're going to return the decrypted password decoded because it's still in bytes. And if this does not exist, then you can return none or something else, whichever works. Okay. And then master input. So when our user runs a program, we're going to ask them to enter a master password. And while this is true, we're going to give them several options. One, they can add a password. And this is just a basic interface. You can create your own interface, but I'm just going to give you one to get started with. You're going to get the password, or you can quit, whichever one you want to do. So we're going to ask them, get the choice. We're going to say, enter your choices. And if the choice is the first option, then we're going to ask them the first. I'm going to ask them what password, and then you can add password, master password, let's say Alex first equals number 2, website equals input website, and we're going to print the response from the get password given our master and the website that we want to. And then ls choice is equal to 3. We can break out. Okay, so I'm just going to create our password JSON file real quick. If I want to. And we should be able to run this now if I didn't make a mistake. So let's say I really do not want to type that. So enter a master password. So let's say my master password is password123. Okay, and we're going to add a password. We're going to say website is google.com. We're going to say that our password is password. Okay, then we're going to get the password, and we're going to say www.google.com, and it's going to return our password. Now, see, if I were to quit, right, and I would run the thing again, if I would say password 245, I would say get password. Okay. Oopsie days. So if I were to say password 245, I say get password, and let's take www.google.com, it's going to return none because it's not the right password, and it's going to fail. Okay, you get me? And you can do a little bit of error handling there if you were up to it. And you basically just check to make sure that, you know, you're actually getting a password back. Okay? And then, you know, choice 3 is pretty simple. So let's say I put my master password, the correct one in. Choice 3 is pretty simple, is quit. So there you go. There's a very basic password manager in Python, full with the security features for the encryption part of it. And obviously you can use a more secure storage system. But this is basically the main idea of what you want to be doing with a password manager if you were to create one. And so yeah, I hope you enjoyed this video. Please leave a like, comment, subscribe if you did, and I'll see you in the next one. Thank you.